So hey guys, welcome back to the channel. In this video, we will understand hydrolysis of salt in detail. Now before starting with this video, let me make one thing clear that I might go a bit slow in this video because although this topic is easy, but it is also confusing at the same time. So to avoid the confusion, I might go a bit slow. And for those who are new to the channel, let me tell you all that I have already uploaded all the previous videos of your chapter Chemical Equilibrium, and the link of the playlist is given in the description box below. Okay, so let's start with this today's video. Now, as we all know that when acid reacts with base, we always get salt plus water. So this is a standard reaction. Whenever acid will react with base, you are always going to get salt plus water. And guys, this reaction is called as a neutralization reaction. Now, suppose if you want to define this salt, so how you can define this salt? An ionic substance produced in the neutralization reaction is a salt. So in simple words, this salt is an ionic substance which is produced during the neutralization reaction. Now, let me make one thing clear that in this complete video, we are mainly going to focus on the hydrolysis of this salt. Okay, so our main focus is on this salt that we have obtained from this neutralization reaction. Now, let us understand first the concept of hydrolysis. Okay, so this salt that we have got dissolves in water, and not only that, when it dissolves in water, the salt dissociates completely into its ions that are nothing but cations and anions. What is the meaning of this? Let's say we have a salt named AB. So this salt AB is going to get dissociated into a positive ion and a negative ion. And guys, this positive ion is called as your cation, and this negative ion is called as a anion. So this is what the statement says, that the salt dissociates completely into its ions that are nothing but cations and anions. And since this salt dissociates completely, therefore this salt is a strong electrolyte. Now, when this salt dissociates completely, at the same time, the water which is acting as a solvent also dissociates to a small extent. Okay, so it does not dissociate much, but to a small extent it also gets dissociated into its ions that are nothing but H plus ions and OH minus ions. Now moving on, as we all know that pure water is neutral. This is the basic thing that we all know. But guys, do you all know what is the reason behind the pure water being neutral? So let's see that. Now if you observe this reaction carefully, guys, can I say that when one H2O molecule dissociates, we get one H plus ion as well as one OH minus ions. Similarly, if let's say 3 H2O molecules dissociate, then we will get 3 H plus ions and we will get 3 OH minus ions. So guys, can I say that the H plus ions and the OH minus ions that we are getting is same, and as the amount is same, therefore the molar concentration of H plus ions is equal to the molar concentration of OH minus ions. And since these molar concentrations are same, that is the reason why pure water is neutral. If the molar concentration of H plus ions was greater, then the pure water would have been acidic. And if the molar concentration of OH minus ions would have been greater, then the pure water would have been basic. But here, since the molar concentrations are same, therefore our pure water is a neutral. Okay. Now, moving on. If the salt ions does not react with water, which means that if the salt ions, which are salt ions, the cations and the anions, if the cations and the anions do not react with water, then the molar concentration of H plus ions will remain equal to the molar concentration of OH minus ions. It is obvious, guys, that if the reaction is not happening between these cations and anions with the ions of water, then the molar concentration of H plus ions will remain equal to the molar concentration of OH minus ions. Let me repeat myself again. If these cations or anions do not react with this H plus ion or OH minus ion, then the molar concentration of H plus ion is going to be equal to the molar concentration of OH minus ions. And if the molar concentrations are equal, then it is obvious that the aqueous solution will also remain neutral. But if one or more salt ions, that is cations and anions, react with the ions of water, that are nothing but H plus and OH minus ions, then the molar concentration of H plus ions will not be equal to the molar concentration of OH minus ions. Now what is the meaning of this? Suppose your salt ions, that are cations and anions, if they react with the ions of water, then the molar concentration of H plus ions will not be equal to the molar concentration of OH minus ions. Now why is it so? That we will see further on in this video. For now, you all just keep in mind that if the salt ions react with the water ions, then the molar concentrations will not be equal. Okay. Now, such a reaction is called as hydrolysis. So the reaction between the salt ions and the water ions is called as hydrolysis. Okay, so I hope you have understood what is a salt, and you have now also understood the concept of hydrolysis. Now, guys, this is the basic reaction that we all know, that acid reacts with base to give us salt and water. But have you ever wondered that we can get 4 different types of salt? How? Let's see. Suppose a strong acid reacts with strong base, then we will get, let's say, salt number 1. Then let's say if strong acid reacts with a weak base, then let's say we get salt number 2. Now there is one more combination possible, that is weak acid reacting with a strong base. In this scenario, we will get, let's say, salt number 3. Whereas there is one more possible combination, that is a weak acid reacting with weak base, giving us, let's say, salt number 4. So it is not just a acid reacting with base to give us salt, but we also need to keep in mind the combinations: strong acid with a strong base, strong acid with a weak base, weak acid with a strong base, weak acid with a strong base. So on the basis of these combinations, your properties of salts, whether it can get hydrolyzed, is going to vary. Okay, so we will first of all understand the salt obtained from the strong acid and a strong base. So guys, what we need to do basically is that we need to find out whether the salt that we have got by the reaction of a strong acid and the strong base will undergo hydrolysis or not. That is the only thing that we need to find out. Okay, so let us consider an example of a salt NaCl, which is obtained when the strong acid HCl reacts with the strong base NaOH. Now, when NaCl dissolves in water, what is going to happen? It will get completely dissociated into its ions, that is Na plus and Cl minus. Next, as we all know that water dissociates slightly as H plus and OH minus ions. So guys, now can I say the aqueous solution contains 4 ions? Which are the 4 ions? This Na plus, Cl minus, H plus and OH minus. So now let us consider these 4 ions. Now there is a possibility that this Na plus, which is positively charged, may form an ionic compound with this negatively charged OH minus. And there is one more possibility that this Cl minus, which is negatively charged might form a ionic compound with this positively charged H plus ions. So let's assume that they are forming compounds. So this Na plus Cl minus will form compounds with the ions, that is H plus and OH minus, and they are nothing but the ions of H2O. So I have simply written them as H2O and will give us HCl. How we get HCl? HCl is the ionic compound formed by H plus and Cl minus. So HCl plus NaOH. And how is NaOH formed? By Na plus and OH minus. But what happens is that this HCl and NaOH, they both are strong electrolytes, and since they are strong electrolytes, HCl will dissociate back into H plus and Cl minus, and NaOH will also dissociate back into Na plus and OH minus. So now can I say that the reaction becomes left hand side as it is, and this HCl gets dissociated into H plus and Cl minus, and this NaOH gets dissociated into Na plus and OH minus. Now what you observe over here is that Na plus and Cl minus ions exist on both the sides of the reactions. If you see over here, this Na plus and Cl minus is present on the left hand side as well as it is present on the right hand side. And if you remember guys, this Na plus and Cl minus are nothing but the ions of our salt NaCl. Okay, so neither the cation nor the anion of the salt, that are nothing but the ions of the salt. Cation and anion are ions of the salt, react with the water. So as you can see over here, since the Na plus and Cl minus, they are present on the left hand side as well as on the right hand side as it is, which means that they have not reacted with water, and we conclude that there is no hydrolysis taking place. Why there is no hydrolysis taking place? Because the ions of the salt are not reacting with the ions of the water, and hence there is no hydrolysis. And if there is no hydrolysis, can I say that the molar concentration of H plus ions will remain equals to the molar concentration of OH minus ions, and hence the equality is not disturbed. The aqueous solution is neutral. Why it is neutral? Because the molar concentration of H plus ions is still equals to the molar concentration of OH minus ions, because there is no hydrolysis taking place. And the salt of strong acid and strong base does not undergo hydrolysis. That is our conclusion. That is, the salt obtained by the reaction of strong acid and strong base does not undergo hydrolysis. So guys, here then we say that this first salt number 1, that is obtained from the reaction of a strong acid and strong base, will not undergo hydrolysis. Now we will check for salt number 2 whether it will undergo hydrolysis or not, and if it undergoes hydrolysis, then what will be its effect. Okay, so this we will see ahead. So guys, now I'm going to teach you on my page, because in this part there is something that I need to explain you all, and I can do it better on a page. Okay, so let us understand whether the salt of strong acid and weak base, whether it will undergo hydrolysis or not, whether it will get hydrolyzed or not. Okay, so let us consider the salt NH4Cl, which is obtained by the reaction of a strong acid HCl and a weak base NH4OH. Now, as we all know that this salt is a strong electrolyte, and this, when dissolved in water, it will get completely dissociated into its ions, that is nothing but NH4 plus and Cl minus. Now, as we all know that even the water which is acting as a solvent gets slightly dissociated into its ions, that is H plus and OH minus. And as we all know guys that for a pure water, the molar concentration of H plus ions is equals to the molar concentration of OH minus ions for pure water guys. Now here can I say that there are 4 ions present. Which are those 4 ions? NH4 plus, this NH4 plus this Cl minus, rather I will write comma H plus and OH minus. So these are the 4 ions that are present. Now guys, there is a possibility that this Cl minus, which is negatively charged, might combine with the H plus ion to form a ionic compound. So there is a possibility that this H plus will combine with Cl minus to give us HCl. But guys, as we have seen just now in the previous concept, that HCl being a strong electrolyte, it dissociates back into H plus and Cl minus. So this HCl will dissociate into H plus and Cl minus. So if you see carefully, there is no change that is taking place. Okay, so these cannot combine, these both cannot combine with each other. So the remaining possibility is that the NH4 plus ions combining with OH minus to form an ionic compound. So this NH4 plus will combine with OH minus to give us NH4OH. And guys, this is not going to dissociate back like HCl. Okay, so this happens where the ion of the salt, can you see this NH4 plus is nothing but the ion of the salt. This is our salt, and this NH4 plus is the ion of the salt, and this OH minus, which is nothing but the ion of water. So when the ion of salt and when the ion of water, they react with each other, can we say that there is hydrolysis taking place? So one thing is confirmed, that the salt of strong acid and weak base will undergo hydrolysis. So this thing is confirmed. But let us see what are the effect on the aqueous solution. What are the effect of this hydrolysis on the aqueous solution? Now guys, if you all know one thing, that for a pure water, can you see over here, for pure water, initially the molar concentration of H plus ions was equal to the molar concentration of OH minus ions. But here, can I say that the OH minus ions, these OH minus ions are consumed by this NH4 plus to make NH4OH. So ultimately, the amount of OH minus ions has decreased. Okay, so let me write it over here. So this, let me write this equation. Okay, this H2O giving us H plus ions plus OH minus. So here guys, can I say that the amount of OH minus has decreased, so its concentration is also going to decrease. And guys, if you notice one thing over here, if this OH minus is decreasing, the concentration of OH minus is decreasing, then the molar concentration of H plus ions will not be equal to the molar concentration of OH minus ions. Why? Because these OH minus have decreased and they are consumed by NH4 plus, and hence their molar concentrations will no longer be equal. Now further on guys, see, now you need to know what is Le-Chatelier's principle, and for those who do not know what is Le-Chatelier's principle, I have already made a separate video on that. You can find the link in the description box below, or you can simply click on this I button which is there on the right top corner of your screen. Now what happens is that as the amount of OH minus has decreased, so can I say that the equilibrium condition has also been disturbed. Now since the equilibrium is being disturbed, so this reaction, so this reaction will try to gain new equilibrium. Let me explain you all. According to Le-Chatelier's principle, if the equilibrium is disturbed, why equilibrium is disturbed? Because the amount of OH minus has now decreased. So as you decrease the amount of OH minus, the equilibrium condition will be disturbed. And if the equilibrium is disturbed, then the reaction will again try to establish a new equilibrium. And to establish a new equilibrium, what it will do? It will try to increase the amount of OH minus. So initially due to the reaction, due to the hydrolysis, what had happened? The OH minus had decreased. But to compensate that effect, the reaction will try to increase the OH minus ions. Now when it can increase the OH minus ions? It is only possible for forward reaction by converting H2O to H plus and OH minus. So if H2O gets converted to H plus and OH minus ions, your OH minus ions will increase. So here what is going to happen? Your forward reaction is now going to dominate and there will be right shift in equilibrium. Okay, so can I say that the amount of H2O is now going to decrease and that much amount of H2O will now get converted into H plus and OH minus. So in this way, if you decrease the OH minus concentration, that is due to hydrolysis, the reaction will again try to increase the concentration. And how it will try to increase the concentration? By converting H2O to H plus and OH minus. But guys, if you observe one thing over here, let's say that initially H plus was 5 moles and initially OH minus was, let's say, 5 moles. Afterwards, can I say that they are decreased? OH minus is decreased. So let's say OH minus decreased to 3 moles. Okay. Now after that, to compensate the effect and to establish a new equilibrium, the reaction increased the concentration of OH minus, and let's say the reaction increased the concentration of OH minus by +1. So 3 plus 1 will become 4. And here can I say that when the OH minus concentration was decreased, the H plus concentration was same. Am I right? So it will remain 5 only. And afterwards, if the molar concentration of OH minus, if the number of moles of OH minus have increased by +1, so obviously the H plus will also increase by +1. So 6. Now, if you observe the initial number of moles and the final number of moles, what is happening over here? That the number of moles of OH minus is decreasing, whereas the number of moles of H plus is increasing. So guys, can I say that the molar concentration of H plus is greater than the molar concentration of OH minus? And this is the reason that due to the hydrolysis, more amount of H plus will get produced. And if the more amount of H plus gets produced, then your aqueous solution will become acidic. So this is the effect of hydrolysis on the aqueous solution, that your aqueous solution has now become acidic. Okay, so do I need to explain here? Let me explain here quickly in less than 30 seconds. Okay, so what happened was that, see, due to hydrolysis, OH minus decreased. Now since OH minus decreased, the equilibrium was disturbed, and to establish a new equilibrium, what happened? The reaction tried to increase the OH minus. And how it increased the OH minus? By converting H2O to H plus and OH minus. So H2O decreased and H plus and OH minus increase. So can you see over here, H plus and OH minus increase. And when H plus and OH minus increase, if you see over here, initially they were 5 moles. Afterwards OH minus decreased, it became 3, but H plus remained constant, 5 only. But after that, when OH minus was increased by +1, H plus was also increased. So ultimate conclusion is that your H plus is increasing from 5 to 6 and your OH minus is decreasing from 5 to 4. So in short, the molar concentration of H plus is greater than the molar concentration of OH minus. So guys, I hope you have understood that salt of strong acid and weak base undergoes hydrolysis, and after it undergoes hydrolysis, what it does is that it makes the aqueous solution acidic. So guys, now let us understand whether the salt of weak acid and strong base will undergo hydrolysis or not. And if it undergoes hydrolysis, then whether it will make the aqueous solution acidic or whether it will make the aqueous solution basic. Let's see that. Okay, so let us consider an example of CH3COONA. So when CH3COOH reacts with NaOH, so when the weak acid CH3COOH reacts with the strong base NaOH, what we get is the salt CH3COONA plus water. Okay, now this is our salt. Now as we all know that salts are strong electrolyte, so this salt will completely dissociate into its ions. So this CH3COONA will get dissociated into its ions, that is CH3COO minus plus Na plus. And we all know that water dissociates slightly into its ions, that is H plus ions and OH minus ions. And guys, as we all know, for pure water guys, the concentration of OH minus ions is equal to the molar concentration of H plus ion. So their concentration is same only for pure water. Now can I say in the aqueous solution, now I have 4 ions. Which are those 4 ions? CH3COO minus, then this Na plus, then I have H plus ion, then I have OH minus ion. Okay, now there is a possibility that this CH3COO minus can react with this H plus ion, and there is one more possibility that this Na plus reacting with OH minus. But guys, even if this Na plus and OH minus react with each other, they are going to form what? NaOH, and NaOH is a strong electrolyte, and since it is a strong electrolyte, therefore it will again dissociate into Na plus and OH minus. So again we are getting the same thing, Na plus and OH minus. So this combination is not possible. So the only combination that is remaining is CH3COO minus reacting with H plus. And they will give us, okay, now this CH3COOH is not a strong electrolyte like NaOH. It is not going to get dissociated into its ions. So this is the reaction that is going to take place. And guys, can you see over here, this CH3COO minus is nothing but the ion of salt. This is our salt, am I right? So this CH3COO minus is a ion of salt, and this H plus is nothing but the ion of water. So when the ion of salt reacts with the ion of water, what happens? This reaction is called as hydrolysis. So one thing is sure, that the salt of weak acid and strong base will undergo hydrolysis. Now let us see what are the effects of this hydrolysis. So here can I say that the H plus ions are consumed. So if the H plus ions are consumed, can I say that the concentration of H plus ions is going to decrease? Let me write it over here. Okay, so the concentration of H plus ions is decreased. Now since the concentration of H plus ions is decreased, why it is decreased? Because it is consumed by CH3COO minus. So no longer the molar concentration of H plus ions will be equals to the molar concentration of OH minus ion. So H plus ions, the molar concentration of H plus ions will not be equals to the molar concentration of OH minus ions. Why? Because H plus ions has now decreased. Now since the H plus ions has decreased, therefore this equilibrium is being disturbed. Now since this equilibrium is disturbed, according to Le Chatelier's principle, the reaction will try to achieve a new equilibrium, and when it is trying to achieve a new equilibrium, it will try to increase the concentration of H plus ions. And how it can increase the concentration of H plus ions? By converting this H2O to H plus and OH minus. So there will be right shift taking place because of the dominance of forward reaction, that is H2O getting converted into H plus and OH minus. So meanwhile, when this H2O decreases and it increases the H plus, it is also increasing the OH minus, because if H2O dissociates, it will give you H plus as well as it will increase OH minus also. It is not only going to give you H plus, okay. So this OH minus is also going to increase. Now ultimately what is happening, let's say your concentration of H plus earlier was 5 and OH minus was also 5, but afterwards let's say H plus decreased, it decreased to 2, okay, and now the H2O tried to increase, and let's say it increased by plus 2, so plus 2 plus 2 plus 2 will give you 4. So now the molar concentration has increased from 2 to 4. But here can I say that the OH minus was constant? When the H plus decreased, OH minus was constant, so it remains 5, and then it increased by plus 2, so 7. So ultimately what is happening, the concentration of OH minus is increasing. The concentration of OH minus is increasing and the concentration of H plus is decreasing. Or in other words, you can say that the molar concentration of OH minus has now become greater than molar concentration of H plus ions. This is a proper framing, that the molar concentration of OH minus ions has become equal to the molar concentration, has become greater than molar concentration of H plus ions. And in the earlier example, you can say that the molar concentration of H plus ions has increased than the molar concentration of OH minus ions. So due to this, if the OH minus concentration increases, then can we say that the aqueous solution becomes what? Basic. So this is what the salt of weak acid and strong base does. It hydrolyzes, and after it undergoes hydrolysis, it makes the aqueous solution basic. And as we all know that if the aqueous solution is basic, then the pH will be greater than 7. Okay. So this was all about the salt of weak acid and a strong base. So now guys, the last part, that is understanding whether the salt of weak acid and weak base will undergo hydrolysis or not, and what will be its effect. Now guys, this part is going to be little bit difficult, so make sure you all pay your 100% attention. I will give my best to make sure that you all understand this part as well. Okay, now let's say guys that I have a weak acid HA. Okay, so I have taken a weak acid HA, and I have taken a weak base, let's say BOH. This is my weak acid and this is my weak base. Now when they react with each other, what is going to happen? The weak acid will give away H and this weak base will give away OH. So H and OH, they will give us water plus the salt. The salt that we get will be obviously BA. Am I right? Now, as we all know that salt is a strong electrolyte. So this salt will dissociate completely into its ions, that is B plus and A minus. Now we know one thing, that water also dissociates slightly into its ions H plus and OH minus. Now guys, can I say that there are 4 ions present? B plus, A minus, H plus and OH minus. Now here there are 2 possibilities, that this B plus reacting with OH minus and this A minus reacting with H plus. And here what is going to happen, guys, both of the possibilities are possible. Let's see how. This B plus A minus, okay, plus H2O. Why I have taken H2O? H2O means the ions H plus and OH minus. I have written them as H2O, and they are going to form the products BOH. How BOH is formed? BOH is nothing but ionic substance that is formed by B plus and OH minus. This connection giving us BOH plus HA, that is H plus and A minus. Now we are sure with one thing, that the ions can I say that the ions B plus, what is B plus? B plus is nothing but the ion of the salt. This B plus is ion of the salt. It is reacting with OH minus. And what is OH minus? OH minus is ion of water. So since the ion of salt is reacting with ion of water and giving us another substance, therefore we are sure with one thing, that it is undergoing hydrolysis. And here also if you observe, this A minus, which is nothing but the ion of a salt, is reacting with H plus, which is ion of water, and they are forming HA. So when ion of a salt and ion of a water react with each other, we are sure that there is hydrolysis taking place. Okay, so we have confirmed that the salt of weak acid and weak base will undergo hydrolysis. But what will be its effect? Whether the aqueous solution be acidic, whether the aqueous solution be basic, or whether the aqueous solution will be neutral. That is the biggest question in front of us. Because here if you see, the H plus is also getting used up and the OH minus is also getting used up. Like in the earlier examples, if H plus was getting used up, then OH minus was not getting used up, and if OH minus was getting used up, then H plus was not getting used up. But in this scenario, both of them are going to get used up. So there's a question whether our solution will be acidic, basic, or neutral. Now guys, this depends completely on the acid dissociation constant value and base dissociation constant value. Now for those who do not know what is acid dissociation constant and base dissociation constant, don't worry guys, I have already uploaded a separate video on this. You can find the link in the description box below, or you can simply click on this I button over here. So guys, let us understand the first case. There are three cases that we need to understand. Okay, so the first case tells us that what if the value of Ka is equals to the value of Kb, and the best example to understand this case is an salt CH3COONH4. Now as we all know that salt is a strong electrolyte, and since it is a strong electrolyte, it will get dissociated into its ions, that is CH3COO minus plus NH4 plus. Now further on, we know that water also dissociates partially into its ions H plus and OH minus. Now guys, can I say that there are 4 ions present? This CH3COO minus, then there is NH4 plus, then there is H plus, and then there is OH minus. Now as we all know that what is going to happen in this case, CH3COO minus being negatively charged will react with H plus, which is positively charged, and this NH4 plus, which is positively charged, will react with OH minus, which is negatively charged. Okay, so CH3COO minus plus NH4 plus reacting with the H2O ions H plus and OH minus, and will give us CH3COOH plus NH4OH. Now guys, here can I say that the H plus molecule of this water is also getting consumed, and OH minus ion is also getting consumed. So H plus ion and OH minus ion, they both are getting confused. They both are getting consumed. Okay. Now, so how to decide whether your aqueous solution is acidic or basic? So for that, we need to find out the Ka value of CH3COOH, and we need to find out the Kb value of NH4OH. Now in this scenario, the Ka value of CH3COOH will be equals to the Kb value of NH4OH. So in this scenario, when the Ka value is equals to Kb, your aqueous solution will be neutral. Okay, clear? For the first case where Ka is equals to Kb, your aqueous solution will be neutral. Moving on to the second case. So in the second case, let's say your Kb value is greater than Ka, and let us consider a salt NH4Cn. So this salt NH4Cn, being a strong electrolyte, will dissociate into its ions, let's say NH4 plus and Cn minus. Now we know that water also partially dissociates into its ion, slightly dissociates into its ion, that is H plus and OH minus. So now there are 4 ions present, NH4 plus plus Cn minus plus H plus, sorry, there should be comma guys, then there is OH minus. So there are 4 ions, this first, second, third and fourth. Now what is going to happen? This positively charged NH4 plus will react with negatively charged OH minus. This negatively charged Cn minus will react with positively charged H plus. So your reaction becomes NH4 plus plus Cn minus reacting with H2O molecules, giving us NH4OH plus HCN. And if you observe over here, your H plus is getting consumed in this reaction and your OH minus is also getting consumed. So now to decide, you need to find out the Kb value of NH4OH and you need to find out the Ka value of HCN. So in this case, what you will get is that the Kb value of NH4OH will be greater than the Ka value of HCN, and since the Kb value is greater, B base, therefore your aqueous solution will be basic. Okay, now let's understand the third case. So the third case where your Ka value will be greater than Kb value, and let's take an example over here of NH4F. Okay, so this NH4F is a salt, and we know that salt is a strong electrolyte, so it will dissociate into its ions NH4 plus plus F minus. Okay, now further on, as we all know that H2O dissociates slightly and produces H plus and OH minus ions. So as can I say that there are 4 ions present now, NH4 plus, F minus, H plus and OH minus. So what is going to happen over here is that this positively charged NH4 plus will react with negatively charged OH minus. This negatively charged F minus will react with positively charged H plus, and your reaction will be NH4 plus reacting with F minus plus H2O. What? These both are ions of H2O, giving us what? NH4OH plus HF. Now in this case, what you need to do is that you need to find out the Kb value of NH4OH. Since it is a base, therefore you need to find out Kb value. Since HF is an acid, therefore you need to find out the Ka value. And when you find out the Kb and Ka value, what you will observe is that the Ka value of HF is greater than the Kb value of NH4OH, and Ka acid dissociation constant. So in this case, your aqueous solution will be acidic. So we have done 3 cases, and we have found out that when the Ka is equals to Kb, the solution will be neutral. When the Kb is greater than Ka, the solution will be basic. when the Ka is greater than Kb, and then in that case your solution will be acidic. So guys, if you like this video, then please do not forget to subscribe to our channel and go check out my channel where you will find videos of physics and chemistry. They might be helpful for you guys. Thank you for watching this video.